1926.1101 Appendix F. Work Practices and Engineering Controls for Class I Asbestos Operations. Non-mandatory. This is a non-mandatory appendix to the asbestos standards for construction and for shipyards. It describes criteria and procedures for erecting and using negative pressure enclosures for Class I asbestos work, when NPEs are used as an allowable control method to comply with paragraph G5I of this section. Many small and variable details are involved in the erection of a negative pressure enclosure. OSHA and most participants in the rulemaking agreed that only the major, more performance-oriented criteria should be made mandatory. These criteria are set out in paragraph G of this section. In addition, this appendix includes these mandatory specifications and procedures in its guidelines in order to make this appendix coherent and helpful. The mandatory nature of the criteria which appear in the regulatory text is not changed because they are included in this non-mandatory appendix. Similarly, the additional criteria and procedures included as guidelines in the appendix do not become mandatory because mandatory criteria are also included in these comprehensive guidelines. In addition, none of the criteria, both mandatory and recommended, are meant to specify or imply the need for use of patented or licensed methods or equipment. Recommended specifications included in this attachment should not discourage the use of creative alternatives which can be shown to reliably achieve the objectives of negative pressure enclosures. Requirements included in this appendix cover general provisions to be followed in all asbestos jobs, provisions which must be followed for all Class I asbestos jobs, and provisions governing the construction and testing of negative pressure enclosures. The first category includes the requirement for use of wet methods, HEPA vacuums, and immediate bagging of waste. Class I work must conform to the following provisions: oversight by competent person, use of critical barriers over all openings to work area, isolation of HVAC systems, use of impermeable drop cloths and coverage of all objects within regulated areas. In addition, more specific requirements for NPEs include maintenance of -0.02 inches water gauge within enclosure, manometric measurements, air movement away from employees performing removal work, smoke testing or equivalent for detection of leaks and air direction, deactivation of electrical circuits, if not provided with ground fault circuit interrupters. Ground fault circuit interrupters. The standard requires that an exposure assessment be conducted before the asbestos job is begun. Section 1926.1101 F1. Information needed for that assessment includes data relating to prior similar jobs, as applied to the specific variables of the current job. The information needed to conduct the assessment will be useful in planning the project and in complying with any reporting requirements under this standard. When significant changes are being made to a control system listed in the standard, see also those of USEPA 40 CFR 61, Subpart M. Thus, although the standard does not explicitly require the preparation of a written asbestos removal plan, the usual constituents of such a plan, i.e., a description of the enclosure, the equipment, and the procedures to be used throughout the project, must be determined before the enclosure can be erected. The following information should be included in the planning of the system: a physical description of the work area, a description of the approximate amount of material to be removed, a schedule for turning off and sealing existing ventilation systems, personnel hygiene procedures, a description of personal protective equipment and clothing to be worn by employees, a description of the local exhaust ventilation systems to be used and how they are tested, a description of work practices to be observed by employees, an air monitoring plan, a description of the method to be used to transport waste material, and the location of the dump site. Materials and equipment necessary for asbestos removal. Although individual asbestos removal projects vary in terms of the equipment required to accomplish the removal of the materials, some equipment and materials are common to most asbestos removal operations. Plastic sheeting used to protect horizontal surfaces, seal HVAC openings, or to seal vertical openings and ceilings should have a minimum thickness of 6 mils. Tape or other adhesive used to attach plastic sheeting should be of sufficient adhesive strength to support the weight of the material plus all stresses encountered during the entire duration of the project without becoming detached from the surface. Other equipment and materials which should be available at the beginning of each project are: HEPA filtered vacuum is essential for cleaning the work area after the asbestos has been removed. It should have a long hose capable of reaching out of the way places, such as areas above ceiling tiles, behind pipes, etc. Portable air ventilation systems installed to provide the negative air pressure and air removal from the enclosure must be equipped with a HEPA filter. The number and capacity of units required to ventilate an enclosure depend on the size of the area to be ventilated. The filters for these systems should be designed in such a manner that they can be replaced when the airflow volume is reduced by the buildup of dust in the filtration material. Pressure monitoring devices with alarms and strip chart recorders attached to each system to indicate the pressure differential and the loss due to dust buildup on the filter are recommended. Water sprayers should be used to keep the asbestos material as saturated as possible during removal. The sprayers will provide a fine mist that minimizes the impact of the spray on the material. Water used to saturate the asbestos-containing material can be amended by adding at least 15 milliliters, 1/4 ounce, of wetting agent in 1 liter, 1 pint, of water. An example of a wetting agent is a 50/50 mixture of polyoxyethylene ether and polyoxyethylene polyglycol ester. Backup power supplies are recommended, especially for ventilation systems. Shower and bath water should be with mixed hot and cold water faucets. Water that has been used to clean personnel or equipment should either be filtered or be collected and discarded as asbestos waste. Soap and shampoo should be provided to aid in removing dust from the worker's skin and hair. See paragraphs H and I of this section for appropriate respiratory protection and protective clothing. See paragraph K of this section for required signs and labels. Preparing the work area. Disabling HVAC systems. The power to the heating, ventilation, and air conditioning systems that service the restricted area must be deactivated and locked off. All ducts, grills, access ports, windows and vents must be sealed off with 2 layers of plastic to prevent entrainment of contaminated air. Operating HVAC systems in the restricted area. If components of a HVAC system located in the restricted area are connected to a system that will service another zone during the project, the portion of the duct in the restricted area must be sealed and pressurized. Necessary precautions include caulking the duct joints, covering all cracks and openings with 2 layers of sheeting, and pressurizing the duct throughout the duration of the project by restricting the return airflow. The power to the fan supplying the positive pressure should be locked on to prevent pressure loss. Sealing elevators. If an elevator shaft is located in the restricted area, it should be either shut down or isolated by sealing with 2 layers of plastic sheeting. The sheeting should provide enough slack to accommodate the pressure changes in the shaft without breaking the airtight seal. Removing mobile objects. All movable objects should be cleaned and removed from the work area before an enclosure is constructed unless moving the objects creates a hazard. Mobile objects will be assumed to be contaminated and should be either cleaned with amended water and a HEPA vacuum and then removed from the area or wrapped and then disposed of as hazardous waste. Cleaning and sealing surfaces. After cleaning with water and a HEPA vacuum, surfaces of stationary objects should be covered with 2 layers of plastic sheeting. The sheeting should be secured with duct tape or an equivalent method to provide a tight seal around the object. Bagging waste. In addition to the requirement for immediate bagging of waste for disposal, it is further recommended that the waste material be double bagged and sealed in plastic bags designed for asbestos disposal. The bags should be stored in a waste storage area that can be controlled by the workers conducting the removal. Filters removed from air handling units and rubbish removed from the area are to be bagged and handled as hazardous waste. Constructing the enclosure. The enclosure should be constructed to provide an airtight seal around ducts and openings into existing ventilation systems and around penetrations for electrical conduits, telephone wires, water lines, drain pipes, etc. Enclosures should be both airtight and watertight except for those openings designed to provide entry and/or airflow control. Size. An enclosure should be the minimum volume to encompass all of the working surfaces yet allow unencumbered movement by the workers, provide unrestricted airflow past the workers, and ensure walking surfaces can be kept free of tripping hazards. Shape. The enclosure may be any shape that optimizes the flow of ventilation air past the workers. Structural integrity. The walls, ceilings, and floors must be supported in such a manner that portions of the enclosure will not fall down during normal use. Openings. It is not necessary that the structure be airtight, openings may be designed to direct airflow. Such openings should be located at a distance from active removal operations. They should be designed to draw air into the enclosure under all anticipated circumstances. In the event that negative pressure is lost, they should be fitted with either HEPA filters to trap dust or automatic trapdoors that prevent dust from escaping the enclosure. Openings for exits should be controlled by an airlock or a vestibule. Barrier supports. Frames should be constructed to support all unsupported spans of sheeting. Sheeting, walls, barriers, ceilings, and floors should be lined with 2 layers of plastic sheeting having a thickness of at least 6 mm. Seams in the sheeting material should be minimized to reduce the possibilities of accidental rips and tears in the adhesive or connections. All seams in the sheeting should overlap, be staggered, and not be located at corners or wall-to-floor joints. Areas within an enclosure. Each enclosure consists of a work area, a decontamination area, and waste storage area. The work area where the asbestos removal operations occur should be separated from both the waste storage area and the contamination control area by physical curtains, doors, and/or airflow patterns that force any airborne contamination back into the work area. See paragraph J of this section for requirements for hygiene facilities. During egress from the work area, each worker should step into the equipment room, clean tools and equipment, and remove gross contamination from clothing by wet cleaning and HEPA vacuuming. Before entering the shower area, foot coverings, head coverings, hand coverings, and coveralls are removed and placed in impervious bags for disposal or cleaning. Airline connections from airline respirators with HEPA disconnects and power cables from powered air purifying respirators, PAPRs, will be disconnected just prior to entering the shower room. Establishing negative pressure within the enclosure. Negative pressure air is to be drawn into the enclosure under all anticipated conditions and exhausted through a HEPA filter for 24 hours a day during the entire duration of the project. Airflow tests. Airflow patterns will be checked before removal operations begin, at least once per operating shift and any time there is a question regarding the integrity of the enclosure. The primary test for airflow is to trace air currents with smoke tubes or other visual methods. Flow checks are made at each opening and at each doorway to demonstrate that air is being drawn into the enclosure and at each worker's position to show that air is being drawn away from the breathing zone. Monitoring pressure within the enclosure. After the initial airflow patterns have been checked, the static pressure must be monitored within the enclosure. Monitoring may be made using manometers, pressure gauges, or combinations of these devices. It is recommended that they be attached to alarms and strip chart recorders at points identified by the design engineer. Corrective actions. If the manometers or pressure gauges demonstrate a reduction in pressure differential below the required level, work should cease and the reason for the change investigated and appropriate changes made. The airflow patterns should be retested before work begins again. Pressure differential. The design parameters for static pressure differentials between the inside and outside of enclosures typically range from 0.02 to 0.10 inches of water gauge, depending on conditions. All zones inside the enclosure must have less pressure than the ambient pressure outside of the enclosure, minus 0.02 inches water gauge differential. Design specifications for the differential vary according to the size, configuration, and shape of the enclosure as well as ambient and mechanical air pressure conditions around the enclosure. Airflow patterns. The flow of air past each worker shall be enhanced by positioning the intakes and exhaust ports to remove contaminated air from the worker's breathing zone, by positioning HEPA vacuum cleaners to draw air from the worker's breathing zone, by forcing relatively uncontaminated air past the worker toward an exhaust port, or by using a combination of methods to reduce the worker's exposure. Air handling unit exhaust. The exhaust plume from air handling units should be located away from adjacent personnel and intakes for HVAC systems. Airflow volume. The airflow volume, cubic meters per minute, exhausted, removed, from the workplace must exceed the amount of makeup air supplied to the enclosure. The rate of air exhausted from the enclosure should be designed to maintain a negative pressure in the enclosure and air movement past each worker. The volume of airflow removed from the enclosure should replace the volume of the container at every 5 to 15 minutes. Airflow volume will need to be relatively high for large enclosures, enclosures with awkward shapes, enclosures with multiple openings, and operations employing several workers in the enclosure. Airflow velocity. At each opening, the airflow velocity must visibly drag air into the enclosure. The velocity of airflow within the enclosure must be adequate to remove airborne contamination from each worker's breathing zone without disturbing the asbestos-containing material on surfaces. Airlocks. Airlocks are mechanisms on doors and curtains that control the airflow patterns in the doorways. If airflow occurs, the patterns through doorways must be such that the air flows toward the inside of the enclosure. Sometimes vestibules, double doors, or double curtains are used to prevent air movement through the doorways. To use a vestibule, a worker enters a chamber by opening the door or curtain and then closing the entry before opening the exit door or curtain. Airlock should be located between the equipment room and shower room, between the shower room and the clean room, and between the waste storage area and the outside of the enclosure. The airflow between adjacent rooms must be checked using smoke tubes or other visual tests to ensure the flow patterns draw air toward the work area without producing eddies. Monitoring for airborne concentrations. In addition to the breathing zone samples taken as outlined in paragraph F of this section, samples of air should be taken to demonstrate the integrity of the enclosure, the cleanliness of the clean room and shower area, and the effectiveness of the HEPA filter. If the clean room is shown to be contaminated, the room must be relocated to an uncontaminated area. Samples taken near the exhaust of portable ventilation systems must be done with care. General work practices. Preventing dust dispersion is the primary means of controlling the spread of asbestos within the enclosure. Whenever practical, the point of removal should be isolated, enclosed, covered, or shielded from the workers in the area. Waste asbestos-containing materials must be bagged during or immediately after removal. The material must remain saturated until the waste container is sealed. Waste material with sharp points or corners must be placed in hard airtight containers rather than bags. Whenever possible, large components should be sealed in plastic sheeting and removed intact. Bags or containers of waste will be moved to the waste holding area, washed, and wrapped in a bag with the appropriate labels. Cleaning the work area. Surfaces within the work area should be kept free of visible dust and debris to the extent feasible. Whenever visible dust appears on surfaces, the surfaces within the enclosure must be cleaned by wiping with a wet sponge, brush, or cloth and then vacuumed with a HEPA vacuum. All surfaces within the enclosure should be cleaned before the exhaust ventilation system is deactivated and the enclosure is disassembled. An approved encapsulant may be sprayed onto areas after the visible dust has been removed.